So if you're feeling pretty confident with the limits that we've been dealing with so far, I highly suggest you trying pages 18 and 19 on your own, and then coming back to the video assignment to check your work. But in the meantime, I'm going to go ahead and actually discuss and walk through what some of these values look like when we're looking at a graph in this case. So the graph is at the top, and we're going to try to evaluate some of these limit values at the bottom. So our first one is we want to approach -3 just from the left. So -3 on the graph is where we have our vertical asymptote, and if we trace the left-hand side, notice how the function goes up forever. So the function is approaching positive infinity. Part B is an overall limit because there's no plus or minus. So we want to approach -5 from both the left and the right side. So trace the left, trace the right. Notice both sides are approaching the hole, and the hole has a height of 4. So the limit as we approach -5 is 4. However, just for practice, if I were to ask you f of -5, which would represent a function value, our answer would be 1, because that's where the closed circle is. So another good example, a limit is what we approach, a function value is actually what we equal. Let's try C. So we're going to approach -1 from both sides. Here's -1, approach left, approach right. Notice how the arrows would eventually touch or meet, and that would happen at a height of -1. We're going to approach -3 from both sides. So there's our asymptote. If we trace the left and trace the right, clearly those are not going to meet up. Okay, so the left and the right side would not match. So our overall limit does not exist. Now we do have to state why. So we can simply say because the left and right limits don't meet or match. Okay, whatever wording or phrasing you want to use. The next one, we want to approach 2, but just from the left. So here's our x value of 2. If we trace the left-hand side, we're getting closer to the closed circle, which has a height of 1. Let's try the next one. If we approach 2 from the right side of the graph, we would be getting closer and closer to the hole, which has a height of 6. So this is going to lead us into part F, which is asking us about the overall limit of 2. And notice how we said the left side approaches 1, the right side approaches 6. Clearly they are not approaching the same real value, so the overall limit does not exist, because the left and right limits don't match or meet, again, whatever wording or phrasing you want to use. Moving on to G, we want to trace the graph towards the left. So on the left-hand side, if we were to go on forever, it looks like we would level off and approach that horizontal asymptote, which has a height of 2. Okay, so that's signifying a horizontal asymptote. And let's try the right-hand side. If we trace the right side of the graph forever and always, we're going to go up forever, so we would be approaching positive infinity. Alright, so we're going to move on to page 19, which is another similar example. Again, if you're feeling confident with this, maybe try these on your own and then double back and check what the video says as some solutions for these limits. So, taking a look at our first one, we're going to go from the left-hand side of -3. So here's -3, and if we trace our graph, it looks like we get closer and closer to the hole, which has a height of 0. Checking out B, we're going to approach -6 from both sides because that's an overall limit. So trace the left, trace the right. It looks like the arrows would eventually meet, and that would happen at a height of -4. Checking out the next one, we want to trace from the right-hand side of -1. So it looks like our graph is approaching a height of 2. Let's say we want to approach -3 from the right-hand side. So here's -3 coming in from the right. We're getting closer and closer to the hole, which has a height of 0. Let's check out 4. So our asymptote is at 4, and we want to trace the graph from the left-hand side. So as you start tracing, notice how your graph stops at the hole, but according to this limit notation, we want to get closer and closer and closer to 4. But notice how that is not possible because we stop at this whole location. Okay, we have no ability to trace anything between the hole and the asymptote. So since this portion is not possible to do, the limit would therefore not exist. So we'll say because the graph is untraceable between x equals 3 and 4. Okay, there's no way for us to approach 4 from the left because we have to stop at that hole at 3. We can, however, trace the right-handed side. So again, tracing 4 coming in from the right, looks like the graph is going to go down forever. So we'd have -infinity. Part G is asking us for the overall limit at 4. So if we were to trace the left-hand side and the right-hand side, would they meet at the same real numbered value? We already analyzed the left and the right-hand side. Clearly does not exist, and -infinity don't match, and they're not real numbers. So this overall limit doesn't exist. Again, we can say because the left and right limits don't match or meet. Moving on to H, we want to approach -4 from the right-hand side. So let's find x equals -4. Trace the right-hand side, and it looks like we're going to get closer and closer to that closed circle, which has a height of about -2.5. Okay, we'll just guess that one roughly. And now let's come in from the left-hand side. So x value of -4, trace the left-handed graph. We're getting closer and closer to the hole, which has a height of -6.